What we're going to do now is we're going to move to our next amazing presenter, talking about build and deploy a serverless web app on GCP. It's my great pleasure to welcome from Google Cloud, Xiang Shen. Zhang, are you there?
All right. Good morning, good afternoon, good evening, everybody. My name is Xiang Shen, and I am a solutions architect from Google Cloud. So I'm based in the Washington, D.C. area. So I live in the East Coast of the United States. So that's very early for me in the morning. All right, let's get started. So just level setting for the agenda. First, I'm going to do some overview about the serverless. That's very exciting and the hot area right now. We have a lot of customers using like serverless services from Google, from other vendors. Then I'm going to talk about the platform, the service we're offering, and give you a high level what they can do, why you should use it. Then talking about some customer scenarios, examples, then I would like to spend a lot of time about a demo to show you and walk you through how a web application running on serverless looks like. So hopefully we have some time for question and answers. Okay, all right. So overview. So if you look at the evolution of compute, so we all start with like on-premises, your own data center. So we have bare metal servers. Then you can install your operating system, run your application on top of it. Then later on, people invent virtual machines. VMware becomes really popular. You can use your resource efficiently with the VM machines, but of course you still have to install OS, patching all your servers, do a lot of work yourself. Then we have containers. Right now, container is still very hot. We have a lot of customers, they migrate to the cloud, just use lift and shift, just migrate their containers over. So container is not really easy. Even you look at like a Docker, you can run one single container within a few minutes. However, if you want to run a meaningful workload, you have to probably coordinate a lot of containers and you have to efficiently use your resources. Then you probably have to deploy some orchestration applications. Kubernetes is really like popular. A lot of people using it. Then in the past we have like a Mesos. We have like Docker Swarm. Still a lot of work for your system admins, but it gives you portability. It makes your resource usage really efficient. The next level would be serverless. When we're talking about serverless, from the word, of course, you would know we talk about there's no server. Meaning you really don't have to like patch a server, install your operating system. You just focus on your code. So that's a different level of abstraction. So if you look at the whole evolution from the on-premises bare metal server to serverless, each level will raise the abstraction. That's really important. If you look at the history of computer science, from assembly language to procedure language to OOP programming to functional programming, we always try to raise the level of abstraction, give us a lot of flexibility, let us focus on our problems instead of managing your IT infrastructure. So, all right. So what are the benefits? So, of course, there's no server. First, it reduces all your management for your infrastructure. And if you look at the security perspective, you actually greatly reduce your surface attack. Nobody can really log into your server. So there's no like SSH terminal can be open for a serverless world, right? So you only pay for your usage. So there's some characteristics about like a serverless. One of them is like a pay as you go. You only pay for what you use. If you don't use it, we can scale to zero, meaning you don't need to pay for anything. I'm going to talk more about when I have like concrete examples, but that's one very important characteristic. From the programming model side, a lot of times serverless really fit into the picture of microservice architecture. So each serverless service a lot of time people think about like function as service or container as service is a microservice. So you have to orchestrate a lot of like microservice in your backend. And the other characteristic is event-driven. So for serverless applications, it's really common you react based upon event. You receive a request, HTTP-based, or you there's event in your storage, in your database, then it will trigger your serverless service or a function, then it will do something. And the last one would be it's open, especially for us. We're really into open source, like from Google. So we open source a lot of our applications, packages. We open source our standards. So for the serverless world, a lot of vendors, players, we work together, really try to move forward with the open source like packages and the frameworks. All right. Now let's briefly talk about the platform Google Cloud Platform offers. So if you look at service, it's not a really new concept. We do have a lot of other services. A lot of people, especially my colleagues in the database, in the data warehouse side, they would like to see their data warehouse, for example, in Google Cloud, it's BigQuery. Then they say, okay, it's serverless. You don't have any servers, right? Like for storage, it could be like AWS S3 bucket, cloud storage from Google. They're serverless. You don't really have any servers can log in. Our other like AI service, Translate, even like Gmail, they are like serverless for you. It's not only for compute. If you look at the portfolio, so we do have like a computer service. Mainly we are talking about cloud functions. You can think about it as function as service. We have App Engine. It's our oldest serverless computer service. Way before like AWS Lambda allows you to upload the code and run it. Then we also have our latest service, Cloud Run, which is a serverless container. It will be today's focus. I really like the service, and I'm going to talk about and demo more about like Cloud Run. So we have all those like storage and the messaging, PubSub. Then we also have those data, machine learning, integration, security. We do have a lot of like service in this area, allow you to develop your application like, in a cloud native way. So, but today, again, we focused on service compute. If you remember the diagram, service compute is really in the core of the serverless world. When you have computing, you really can have your business logics and applications based upon a serverless platform, allow you to really open your horizon to develop your service-based applications. Yeah, if we look at the spectrum, from computer engine to Firebase, as I mentioned earlier, it's different levels of abstraction. But we understand there's no like one size fit all. A lot of times, like for example, you have some legacy applications you have to run on a server, you still have to choose like compute engine, meaning it's a VM-based solution, right? So you get a lot of flexibility and the control over virtual machines. And on the right side, if you move to higher abstractions, then you have less control, but you have less stuff to manage. You don't have servers, you have a high availability and scalability all coming from Google, and you can really speed up your development cycles. And in this diagram, I don't really have a Cloud Run over there because the structure I put into that is like I'm going to talk briefly about the App Engine and the cloud functions, then we move to like a serverless container. We're going to spend more time on that. Then the Firebase is our mobile backend service. So it has database, storage, and authentication, all those types bundled together for mobile developers. All right. First, let's take a closer look at App Engine. So App Engine is really easy to use. You can only need one YAML file called like app.yaml for like a basic deployment. Then you can just use Gcloud, our CLI, or our console to deploy it with minimal like configurations. It's our oldest serverless service for the compute side. A few years earlier than all the other vendors. Auto scale and the pay what you use, so it really fits the serverless characteristics. It's not really container based. It's based upon gvisor. It's our sandbox. It's similar to container, but it's our implementation. So next one would be functions. A lot of people think about function as service, meaning you develop your functions, a piece of code, a microservice, you upload it, and you just run it. Famous example would be AWS Lambda, right? You write some code, could be Python, even Ruby, or whatever language, you upload to AWS, then they run it based upon events. It's similar. We have our cloud functions, which is also event-based. You write your code, you specify your entry point, then based upon events or the HTTP request, then we run it for you. It's a little bit different than Lambda. We do give you a secure HTTP endpoint, so you can just run it from there. But the authentication piece is a little bit different. So in my demo, you will see it can be a great fit for web backend, but if you want more power or more control, then you probably should look into like App Engine or Cloud Run, like service container. So let's look at some custom examples, scenarios. For App Engine, as I mentioned, it's our oldest serverless computer service. We do have a lot of customers using it. One of them would be Khan Academy. It's nonprofit organizations offering online courses over like 40 million people. I would think at this moment, they probably have more customers, more students, more kids to use their service. App Engine really allows them to scale and have a high availability of the service. So this is a reference architecture close to their implementation. It's not exactly the same because they all obviously have a more complex architecture and the services, but that's very similar. So you can see the users, when they hit their website, download the static assets, they're going through a CDN, content network. Then if the content network, you can think about it as a cache layer. If it's not in the cache, they're going to fetch from cloud storage. It's our object-based storage. They're like buckets. In the buckets, you have objects. You can save them over there. Then that's for the static web page, videos, like audios. Then for the dynamic ones, when you hit some APIs, it goes through the App Engine. Then the App Engine is going to asynchronously put some stuff into their pub subs. Then the backend can process, like do business intelligence analysis. And for the front end, then they just talk into the cache. And of course, in the App Engine, they have their code. They can do a lot of processing and do a lot of stuff. One thing I want to point out is we do have an open platform, so we really don't force you to use our services, right? So their CDN actually is a different vendor, not from us. We do have a CDN service, but they already have some CDN service using and have a contract, so they're using different cloud CDN. So that just shows the openness of our like a platform. And in this diagram, of course, your App Engine can talk to your own APIs. If you have data centers or you have some other stuff, you can do that as well, right? It's highly available and scalable. Based upon how many students or how many kids hit their website, it will scale up, and meaning we have a lot more instances running, or it can scale to 0, then you don't need to pay for anything. So keep in mind, that's a very common architecture in the serverless world, not only for App Engine. You can replace it for like cloud functions or a container from like Cloud Run. So, but typically it's the same. You have the static assets in a bucket or cached by CDN. Then you have the business dynamic stuff from your App Engine, from your code. Then you have like backend. Could be a database, could be storage, could be a caching service, right? So Super Mario, if you remember that Nintendo like launched on Google Cloud a few years ago, it's really popular. Suddenly a lot of people play it, and then they use the App Engine as well. They use it more like as a backend because this game, if you play with it, it's on a mobile phone, right? But their backend API service or host on App Engine. So it's more complicated compared to the previous one. So you can see they have like authentication service, they have push notifications, they have analytics, but the the idea would be, yeah, you have a dispatcher. So in the app engine, you can have multiple services. Then you can have a dispatch YAML file to dispatch to a different services based upon the, like, for example, the slash different URL. Then they have a backend using Firebase. It's our mobile backend, as I mentioned, to do a lot of mobile stuff like push notifications. Then they, of course, save our logs to do log processing. And they also use a bunch of our services. Some of them are not serverless, but for the game, to power up the game, it's all like App Engine based. So their game server runs on App Engine, allows them to really scale up. And then if there's no player, like for example, in the middle of the night, they can scale down. So, all right. So, okay, let's switch to our demo real quick for App Engine. So it's a live demo. Live demo is always a little bit tricky. So hold on. So I'm going to open my console. And my terminal. Okay, so for App Engine, we do support a different language like PHP and Python and the Node.js to deploy. So I'm just using a PHP example. So for a lot of folks, PHP is still very popular in the web application side. A lot of PHP developers, you probably have some legacy applications. You don't really want to reprogram them based upon like cloud functions or Lambda. You just want to deploy them, run a service. If there's not a lot of traffic, you want to scale to 0, so you don't want to pay for them. So here I just have a very simple like hello world. If you're familiar with like PHP, then it's like hello world echo. Then if you look at some things, I have the runtime. So that's app YAML file I'm talking about. You can specify the entry point. You can specify like environment specification, like instance types, those type of things. It's really simple. So, and if we go to already deployed, just to save time. So first I want to show you the dashboard. So App Engine really have a nice dashboard to give you the metrics. So then if you look at the service, that's a service I deployed. Yeah. Oh, ready? Let me try again. Can you see now?
Cool.
Okay. So if I just run it just like hello world, very simple, right? That's the application from here. Let me. Can you see my terminal? Hello. Oh, okay. So just quickly show you how to you can deploy it real quick. So I just want to make a change like hello world from DC. Okay. So I make this change, then I can just deploy it. To deploy. So it will ask me some questions. Of course, you can specify from the command line interface, right? Here I just say yes. So it's going to upload one file, then going to deploy it. So if I switch back, then go to the service. It probably takes some time. It's not there yet. I can look at the versions, right? If we deploy, then we're going to have like different versions of the same applications. Then if you look at it, that I have like 2 versions already deployed. Right now, my one version serves like 100% traffic. Then I can select them. I can split traffic, give them like 50-50, and then you can do like blue-green deployment or sort of load balancing based upon different. Then see my new version is deployed. So if I click it again, then you say, yeah, from DC. So it's really quick, right? Takes like not even a minute to deploy like a simple application. It's already there, right? So I can like split, I want to show you the split traffic thing. So I can click split traffic. You can do it based upon like IP address. Did I select both? So I say random. version. So I want to add an older version. Let me see, like a 50% and roughly. Say save. Then if I go back, yeah, it's random. It's probably cached in my browser. Open a new one. Probably cached again. Did I save it? Okay. So let me go back to see my split traffic. It shouldn't probably, okay. Try it again. Random add version. Let me just add old version. Save. Okay, it's updating. Sorry, probably didn't clear the button correctly. Okay, let me go back. Refresh. Yeah, see, it's changed. So let me try again. See, it's go to my old version. And if I refresh a couple times and go to my new version. So that's how split traffic. So really easy. So to do that, then you can have other capabilities like set up a queue, set up cron jobs, and do like firewall rules. And as I mentioned, we do have a dashboard to show you all those like metrics really easy. So if you have some like a PHP or like Python based or any like web applications, you can use App Engine, then it's really easy to deploy and maintain. So that's my quick demo about the App Engine. So, okay, I'm going to go back to my deck. Can you see my deck? Okay, cool, great. So, okay, that's the one. Sorry, I probably accidentally clicked that one. Okay, so Cloud Function is our like function and service, the serverless service. First, I want to talk about is not really a web application. It's an IoT-based solution. So a lot of customers or users, they have IoT device like sensors deployed everywhere, even like mobile phones. They want to capture all those telemetry, all those messages. They want a very powerful backend, and Cloud Function would be your fit. It doesn't process a lot of like logics, doesn't need a lot of processing power, but it needs to be react really quickly to events. So that's the reference architecture. So think about if you're going to like a parking space now, we have all those lights, red, green to indicate the parking spot, then that's one of our customers to use this backend. They send events into our IoT like core service through PubSub. They distribute the message into Cloud Functions, and then they save into database or send some other message back. So that's how it works. The powerful about this architecture is you really can scale very well, and you only pay for what you use, and easy to deal with real-time data and events. So another example, very common for function as service, is React to storage-based event. Typical use case would be somebody upload an image into your storage in your bucket. Then the bucket has event to trigger your function. Then your function, like for example, can resize the image or parse the image or label the image. And based upon this information, they can save this metadata into your database or upload the thumbnail into another storage and allow your users download. That's very common use case in our platform or in AWS, and they have their reference architecture about how you're going to upload a file into S3 and trigger the same type of like functionality. And Domino's is a pizza like delivery really big in United States. Then they also use cloud functions to allow their customers to quickly send event to their backend. Then they can process it. So you can see they allow us to use different devices, even different channels, like from Slack, from Messenger, to send event into Cloud Functions via HTTP. Then they send those events to their data store. Then they also send them to like AI service, like machine learning, and try to make sure they do the right thing, deliver the correct pizza to your home, like for example. Right? So, okay, let me just do a quick demo to show how it works. Let me bring back my browser. So the application I want to show you is based upon web. So that's something I did a few months ago. If you look at the simple web application, hit a load balancer. So the load balancer hits storage bucket, have my static assets. I'm going to show you this later, but that's just a simple like registry form, right? So, okay. If you look at, and what I hit is actually load balancer. So that's my load balancer. You can, like in different vendor or different platform, you can use the CDN to bridge proxy your events to your backend. But here I'm just using a load balancer. Let me make it big for you guys. So the nice thing about Google load balancer, it could be like global. Then you can associate a certificate. So you can have HTTPS on top of it. If you directly serve your web page from your cloud storage bucket or S3 bucket, the downside would be there's no way you can upload a certificate. So all the traffic would be HTTP based. If you want them to be HTTPS based, you want to have a certificate associated to it. Then you can see I have a bucket over there. If I go to my bucket, it's really simple, right? In my storage bucket, I just have like my register.html. So that's the page I'm serving here. So let me open the page source for you. So if you look at my source code, I only have like a very simple like Java script over there. It's not even fancy, based upon jQuery. I didn't use any like fancy like React or JavaScript framework. If you can look at this, I do have an AJAX call, post a message into an endpoint. This endpoint is my Cloud Function endpoint. So let me go back to my Cloud Function to show you real quick. So my Cloud Function is here. So that's my Cloud Function. If I go into it, so if I look at the trigger, that's the URL I'm using in my web page. So let me click edit to show you how the code looks like. It's Python based, so you can use some different language. We do support different runtimes like Go based, Java based, Node.js, or even Ruby. It's in Alpha. So if you're familiar with like Python, I install like some libraries. You can put them into requirements.txt. Then I just return the message back and save into the data collection, which is my database. So real quick, my database. So that's my data set, right? So right now I have like two data sets. You can think about as just data entries. So let me just do another one. So yes. Oh, yes. Just submit. Yeah. Probably should open the inspect and it's already successful, so it's a bit late. But I'll go back to my data store and I'll refresh. So you can see like I have like 3 now, right? That's my Google one. It's the timestamp here. That's another one. That's my Gmail, my Hotmail, and you now all know my emails. So that's the one I just submit. So that's how it works. So you just use as the endpoint, API endpoint, like serve your dynamic content. So that's just one simple example. Of course, you can. I'm doing a post. You can do a get. You can do a lot of different things from your backend. So that's my quick demo about my cloud functions. All right. So in interest of time, let's move to the serverless container, which is my favorite topic right now. So it's really innovative, I would say. It allows you to run a container in a serverless fashion. So it's stateless as all the other serverless service, function-based, code-based, app engine-based. You should always think of them as a stateless, because in a serverless world, your microservice, your compute unit, usually they're not persistent. When they finish the processing, process event or request, they're going away. So you don't really want to save any state in local storage, for example. You always want them to save a thing to a database in a cloud storage, and it's response to event, and it auto scale based upon events. And we also do a health check for you. And it's based upon open source framework called Knative. That's contributed by Google and worked with other collaborators. It's a building blocks for the service containers. I don't want to spend too much on Knative, but if you're on Google, then you will see Knative is used in different places, especially for a lot of Kubernetes distributions. So we do offer 2 flavors right now. It's fully managed. You can upload your container and just do a minimal configuration, and you can just run your containers. The other one would be based upon Anthos. Anthos is our platform, allow you to run workloads across platforms in a hybrid cloud or multi-cloud, and run any GKE cluster or your own Kubernetes cluster. So that's Cloud Run over there. So pay-per-use, how it works is we charge you based upon how much CPU memory and how many requests you have. It's run to 100 milliseconds based upon that. So if you look at the request, if we have multiple requests coming from the first request to the last request, that's the time we charge you. That's your billable time. We don't charge you if you don't have any requests. The nice thing about service container Cloud Run is it does allow you to have concurrent requests coming. A lot of times, if you look at the service world, event-based, they only process one event at a time. And then if you have multiple events, they have to start up multiple instances. For Cloud Run, we do allow you to currently have up to 80 concurrent requests. So it will save you cost, meaning one instance can process multiple requests simultaneously. So for a lot of applications, for example, Spring Boot or Node.js, they can have multi-threading or accept multiple requests simultaneously, then it will save your cost. So use cases, again, we can serve website, API endpoint, mobile webhook, and a lot of times you have a microservice kind of architecture. You can run them privately inside your VPC, serve them as asynchronous tasks on microservices. So that's very high level. I want to show the demo, how it looks like, so you can have more idea. So this time, let me switch to my different account. So I already have this open. So you probably see it, or you might see it from some other places. And the thing I want to show you is called convert to PDF. So the website is really simple. I already have a custom domain name associated to it. Allows you to upload a file or point to a file, then convert the doc to PDF. For example, I have the one over there. You can pass it. Then basically converts a doc file to PDF. So very quickly, how it looks like. I have a repo, and it's container, it's a service container. So you have a Docker file. So it's Python based. The nice thing is because it's container, you can install really heavy dependencies or binaries. Like in my example, we actually install the LibreOffice, which is sort of like an open office. And usually you cannot install those type of binaries on Cloud Function or Lambda because it's too big and takes a lot of time. Then we just create these containers. So nice thing about this Docker file is you create a container, you can run it anywhere, right? So for the application, it's a Python like Flask-based application. It's really simple. We allow some extensions, doc, express sheet, and then we have the root. We can get the web page. We can, when you post a file, we're going to convert it. We just convert the file using the LibreOffice to convert to PDF. So that's how it works. As I mentioned, this is in a repo. So this time I do want to show you how like CI/CD works, continuous deployment. So if you remember in my website, I do have this type of typo like title, so like service convert. So let me just make some small changes. Actually, I can make it this. So it's index, that's a template. Let's say only. Don't want, if you use this one, use like convert a picture, then you get like internal error, right? We don't support that, so we can only do this. Then add the templates in that file. Oops. Commit the file. It's a test, so I just going to push it. So how it works here is you can use a Git repository, but I'm using our own repository in Cloud Source. So I do have a source repository here. Just go to my source repository. So you can see I commit my change here. So once I commit a change, it has a trigger my build process. So that's how continuous deployment work. I'm using like Cloud Build. Of course, if you have like Jenkins or any other like CI/CD tools, you can use it. You can see my like build kicks off. So it's running the build. I'm going to build my container, push to the container registry provided by Google. So once it's done, I'm going to just deploy it, and then I'm going to refresh my page. So if we go to the repository, and you can see for Cloud Build, I just need to specify the steps I'm going to use. So for the DevOps folks here, similar to Jenkins, right? You specify steps. The first step would be I build my Docker container based upon my code commit like hash, and then I'm going to just push to my registry here. Could be Docker Harbor or some other registry. I'm using using a Google one. Then I'm going to like deploy it as a service container. If you look at the command, it's really simple. I specify service, my image, and the region, and I use like the fully managed service. Here, allow authenticate basically means it's public website. If you want to specify some authentication, you don't specify this, it will be private and need authentication. So it does take a little bit of time to deploy. The other thing I want to show you real quick is about scaling. So I do have a test over there, and if I click this one, I already did some testing. So in interest of time, I probably don't want to do it again, but you can see it from the diagram. It has some spikes over there. Those spikes means cold start. So for a serverless service, one terminology you would see a lot is called cold start, meaning the first time you hit your service, your endpoint, then it's going to just bring down your code in a container or in a function. Then it takes a little bit more time. So if you have a lot of it's the first time you have a lot of requests, for example, then you want to see those like latency over there. It takes a little bit more time to run my code, and afterwards it will serve like come back to normal, right? Let's save. Still deploying. So the next thing I want to show you is another application called the Spring Boot Pet Clinic. That's a very famous demo like application from way back. I don't remember, like for like Java Spring Boot or Java Spring based framework. So if you have those type of applications, you can just simply like containerize it and deploy it to Cloud Run. So already deployed. The downside about those type of applications is Spring Boot is really heavy. It takes a few seconds to load. So if I refresh, because that's my first request since like yesterday, so it takes a little bit of time to load, and afterwards it will be really fast. And while it's loading, then if we go back to my Cloud Run tab, you can see this is deploying. Then I have my Spring Boot application over there. So if I go back to like 7, one day load. Yeah, you can see the metric is coming. So if you look at the latency over there, you do have like a spike that's caused by the cold start. But if I go back, when it's up, then it's really fast. So it takes a little bit of time. So really nice way to containerize your legacy applications, Spring Boot, those type of things. If you don't want additional work, you don't have a lot of traffic, it's an internal web applications, or it's your personal website, you can just convert them to a container. We even have a tool called, if it's Java Spring or Java based, we have a tool called GIB. You can just use it. It automatically creates a container image for you, upload, then you can just deploy it. So it's a really simple way to move to the cloud. And let's see if my CI/CD process is okay. Everything is deployed for my other applications. Then let me just try to refresh. So you see, the first time I hit, because it's a new version, it takes a little bit of time to load. Then if you look, I have the omelet here. Let's try to run it again to see if I can upload the file to make it a PDF. Converting. So yeah, that's just an example, like doc file, like business letter. So, all right, that's my demo. And for Cloud Run, because of time, I don't want to